Okay, this is something new, something that we haven't worked on together yet. So it says find the slope and the y-intercept of the line represented by each table. So we've worked on finding the slope and the y-intercept of a graph. Remember, slope was rise over run, or it was the change in the y values over the change in the x values. And the y-intercept was simply wherever the line was crossing the y-axis. So far with tables, we have talked about seeing if the table had a constant. And remember, that was taking the y value and dividing it by the x value. So if I start this table with the way that we've been doing our table, so 22 divided by 2, and then 32 divided by 4, notice that it does not have a constant. So I'm going to show you how to get the slope out of a table that does not have a constant. So since I know this does not have a constant, I know it's non-proportional, so I'm going to write this equation. Y equals mx plus b. Remember, m is our slope and b is our y-intercept. The first thing that we're going to work on getting from this table is the slope. And I want you to write m equals the change in the y values over the change in the x values. So I'm going to go up to the table and I need to look and see how did it change from this first y value to the second y value. So this one's pretty easy to see that it went from 22 to 32, so they added 10. If you cannot tell how much they are adding, like maybe if it wasn't simple numbers or even if you had some negatives or some decimals in there, all you have to do is take this y2 value and minus the y1 value, just like we did whenever we did finding the slope between two ordered pairs. So you can just take that second one, type it in, so 32 minus the y1 value, okay? Now I'm going to go get the change in the x value. So I need to see, did it increase or did it increase and by how much? So I can see that it went from a 2 to a 4. So it's easy for me to see that it added 2. So I'm putting that with the change in the x. Remember that for slope you always want to reduce it, and this one can reduce down to 5. So I just found the slope of the table by seeing how much are the y values changing, and the sign is important, over how much are the x values changing, okay? Now it wants me to find the y-intercept, which is the b. So if you think about this equation, because I've got a table with x and y values, and I now have my m, well, I can fill in a number for x, and I can fill in a number for y and m. So if I fill in all of these variables and that only leaves me with one variable, then I can solve it and I can get my b number. So I need you to write y equals mx plus b. We just got the m, or the slope, of a 5, so fill that in for m. I can go to the table and get my first x value was a 2, so right under the variable x, the table told me a 2. You can bring down the equals. I need to get a y number, and I have one right here in the table. Since I got the first x, I'm going to take that first y of a 22. So I filled in a y, an m, and an x. All I have left now is the back part that says plus b. I can solve this for b to know my y-intercept. Okay, so right now I ask myself, well, what can I do to make this equation get shorter so that I can isolate the variable b? Well, right here it's telling me to multiply, so I work that part. 5 times 2 is just 10. I'm only going to work one step at a time, and then I bring the rest of the equation down. If I want this variable to be all alone, I look and see, well, what's beside it? I need to make that go away. There's a positive 10, so I need to minus 10 from both sides of the equation. So now the b is isolated. I do 22 minus 10, and I get 12 for the y-intercept. Now I'm going to write the equation for that table, because I know that the slope was 5, and I know the y-intercept is 12. So on this line, write y equals, remember it goes m, and I got a 5 there. So y equals 5x plus 12.